For the binomial expansion in ascending powers of x for 1 plus a quarter x to the power of n, where n is an integer and it's bigger than or equal to 2, find and simplify the first three terms. So we're doing the binomial expansion for 1 plus a quarter x to the power of n. Our first term would be n choose 0 times 1 to the power of n times a quarter x to the power of 0. So I've done it that way because we want ascending powers of x. So I'm starting with x being to the power of 0. Our next term, n choose 1 times 1 to the power of n minus 1 times a quarter x to the power of 1. Final term, n choose 2, so we're increasing this bottom number here, n choose 0, 1, 2. Decrease the power for 1 again. And finally, we have the quarter x squared. And this will keep on going. We'll have a total of n plus 1 terms overall. Okay, so we need to simplify this. So anything choose 0 is just 1. So n choose 0 is 1. The 1 to the power of n is also 1. Anything to the power of 0 is 1. N choose 1, anything choose 1 is that number itself. So that would be n. This is again 1, and this will be a quarter of x. I'll come back to this in a sec. I'll just do these two terms first. So a quarter x squared would be a 16th of x squared. And then this is also 1. Okay, so n choose 2. Let's deal with that first. So n choose 2 is the same thing as n factorial over n minus 2 factorial times 2 factorial. And this is the same thing as, the numerator can be written as n multiplied by n minus 1 times n minus 2, and this will keep on going all the way down to 3, 2, 1. And then for our denominator, we have n minus 2 factorial, which is n minus 2 times n minus 3, all the way down to 3, 2, 1. And then we have the 2 factorial, which is 2 times 1. So what we have here is n minus 2 times n minus 3 times n minus 4, n minus 5, etc., all the way down to 1. And that's actually the exact same thing as what we have here. That portion of the n factorial is n minus 2 times n minus 3 times n minus 4, all the way down to 1. So what we have there is n minus 2 factorial, as again is what we have here. That's also n minus 2 factorial. So those two things can cancel out. This cancels with this, and then what we're left with on top is n times n minus 1, and on the bottom is 2 times 1, which is 2. So just this is what's left on top, this is what's left on the bottom, and that simplifies to make this. So that is what our n choose 2 is equal to, n minus 1 all over 2. So let's simplify this now. So this is equal to, the first term would be 1, all of these 3 times together. These 3 multiplied together would be n over 4 times x. And our final term that we're considering, we have 16 on the bottom, 2 on the bottom here. They become 32. So that term becomes n times n minus 1 over 32 times x squared. And again, this continues. So that's part A done. For part B, find the value of n for which the coefficient of x is equal to the coefficient of x squared. Alright, so the coefficient of x is n over 4. The coefficient of x squared is n times n minus 1 over 32. Coefficient is the term next to the x or the x squared. Those two things are equal. I'm not going to cancel out the n's as we'll lose solutions if we do so. I'll bring the 32 to the left. 32 divided by 4 is just 8. So this becomes 8n is equal to n times n minus 1. I'll then bring everything to the right, and then I can factorize this. So I've just brought this to the right hand side. I can now factorize, take out a factor of n, and we're left with n minus 1. That's what comes out from this first term. And the second term, if we take out n, will be minus 8. That will be left over. So that is n times n minus 9. So we have two solutions. N is 0, n is 9. Now, n can't be 0 because we wouldn't have a binomial expansion if that were the case. We're also told that n is bigger than or equal to 2. So again, n is the power, so it can't be 0. We wouldn't have an expansion for this if that were the case. So n must therefore be 9, and that would be our final answer.